This is lesson 4-1, congruent figures. Remember, the word congruent means that the lengths are the same. So congruent figures have the same size and the same shape. You can slide them, you can flip them, or turn them so that one of them fits exactly on the other. So congruent figures have the same size and the same shape. The sides are going to be congruent to each other, the angles are going to be congruent to each other. And there's an example of a picture here with each of them. So if I slide it, okay, this one would fit exactly on that one. If I flip it, that one fits exactly on this one. If I turn them, okay, or rotate it, this one would fit exactly on that one. So those are congruent figures. And each of these slides, flips, and turns are a transformation, which we'll talk about later on in the year. But basically, congruent figures have the same size and the same shape. Congruent polygons have congruent corresponding parts. They're matching sides and angles. So congruent polygons have congruent corresponding parts. The corresponding parts are the sides that match up to each other and the angles that match up to each other. So if you look back here in this quadrilateral, this longer side right here matches up to that longer side right there. Okay, so congruent polygons have congruent corresponding parts. We're going to talk about those corresponding parts. When you name a congruent polygon, you have to list the corresponding vertices in the same order. Now this example right here, we have the corresponding parts are color coordinated. So angle A corresponds with angle E, angle B corresponds with F, C corresponds with G, and D corresponds with H. So if I'm saying that A, B, C, D is congruent over here, I have to put the letters in the same order. If I choose to go A, B, C, D, okay, the A matches up with the E, and the B matches up with the F, I have to say E, F, G, H. And you can see that right here. A, B, C, D is congruent to E, F, G, H. Okay, so the corresponding vertices have to be in the same order. If I didn't have the picture, and I just told you A, B, C, D is congruent to E, F, G, H, then you know that the A matches up with the E, the B matches up with the F. So I say, what angle is congruent to angle D? Angle H is congruent to angle D. What BC is congruent to what other side? BC, it's the second and the third letter, are congruent to FG because it won't be color coordinated. All right, now we have a third angles theorem. The third angles theorem says if two angles of one triangle are congruent to two angles of another triangle, so we're going to look at the picture right here. I have two angles of this triangle are congruent to two angles of another triangle. And I know that angle A is congruent to angle D. They're the same color, but I also have this one little arc mark. So the one arc mark matches up with the one, and angle B matches up with angle E. And let me just give them a number so we can see. Say angle A was 40 degrees and angle D was 40 degrees. They're congruent. Angle B is 60 degrees and angle E is 60 degrees. They're congruent. Well, if A is 40 and B is 60, that's 100. What's left for angle C? Remember, what are the angles of a triangle equal? 180. So angle C would be 80 degrees. If angle D is 40 and angle E was 60, again they add up to 100. What's left for angle F? 80. So if two angles of one triangle are congruent to two angles of another triangle, then the third angles have to be congruent. Okay, if two angles of one triangle are congruent to two angles of another triangle, the third angles, they have to be congruent automatically. So if angle A is congruent to angle D and angle B is congruent to angle E, then angle C has to be congruent to angle F. So we actually only need two angles congruent, and then we automatically know the third angles will also be congruent. And we can use that theorem in our proof. Okay, if you need to pause and copy that down, you can. We're going to try it and do a proof to prove that two triangles are congruent to each other. So to do that today, we're going to show that all three sides are congruent to all three angles. In the future, we're going to shorten that up a bit, but the first one today, we're going to do it like that. So I'm proving triangles are congruent to each other. Okay. I have a given, I have a picture. Now notice the picture is marked for you. It won't necessarily be marked. You'll be marking the picture with the given. So LM is congruent to LO. So I used one little slash mark. LM is congruent to LO. MN is congruent to ON. I used two slash marks. Angle M is congruent to angle O. So I use this little arc mark, one of them. And angle MLN is congruent to OLN. So right here, these two angles are congruent, and I use the two little arc marks. And I want to prove that LMN, triangle LMN, is congruent to triangle LON on the bottom. Okay, so let's think about it. How many conditions do I need to prove the two triangles are congruent? And how many conditions do I have? Like, how many sides do I have congruent right now? I know that LM and MN are congruent, so that's two sides. And I know, and down here I have the corresponding sides LO and ON. So I have two sides. I need the third side, so we got to think about how am I going to get that third side. And how many angles do I have? I have two angles. I need three angles. How am I going to get that third angle? So remember, when we're starting with a proof here, we have our statements on the left and our reasons on the right. So I have my statements actually all listed. You're going to just fill in the reasons. I have LM is congruent to LO, MN is congruent to ON. Now this is just listing the sides, and the angles are listed in statement 3. You can list these all together in one statement because they're all given. Okay, so I have my two sides. So remember, I have my two sides. Let's think about how we're going to get the third side. What do I know about this third side that's not marked? LN. Well, actually, LN is shared. It's in both triangles. It's in the top triangle and it's in the bottom triangle. So LN is congruent to LN. Try and think about what that reason is without me showing you. If something is shared, if something is congruent to itself, remember that's called the reflexive property. And that's this reflexive property of congruence. We can just write reflexive property. That would be fine. Okay, so now I have the third side, and you can make an X right here to show that third side. That's what I usually do when they share a side like that. Now I'm going to list the angles. I have angle M is congruent to angle O, and angle MLN is congruent to OLN. And again, that was in the given. So I have my two angles. How can I get the third angle? Well, I'm going to use that third angle theorem that we just learned about. If these two angles are congruent to these two angles, then angle MNL over here has to be congruent to angle ONL over here. Okay, so I have that listed already as a statement. And the reason is going to be my third angles theorem. Now I have, and you can mark it on your diagram also, I have all three sides congruent to all three sides, and I have all three corresponding angles congruent to all three corresponding angles. So now I can say that triangle LMN is congruent to triangle LON. And that's my definition of congruent triangles. If all three corresponding sides are congruent and all three corresponding angles are congruent, then my triangles are congruent. Okay, and that's it for today. And later on in this chapter, okay, tomorrow and the next day, we're going to learn a shortcut so we don't have to show that all three sides and all three angles, because that's 6 things that you would have to put into a proof. There are shortcuts to do that. Okay, so we'll do that tomorrow night.